The pull tool is probably the most important tool to learn how to use in DesignSpark. And in this video, I'll show you all of the options and how to use them. The pull tool is at the heart of turning two-dimensional surfaces into three-dimensional solids in DesignSpark. So this is a huge topic because there are so many different features and options available in the tool depending on what you're trying to accomplish with it. So to get started, let me Control Z to back up here. So just like other tools in DesignSpark, there are two places that we need to look for the features and the options. So the features are all buttons that are going to be in the upper left-hand corner of the work area on the user interface. And then in the options column on the left is where the options are, and they will change depending on what feature we have selected and what item we have selected in the design. If we look across the top, here's the first three that we can discuss. The first one is to add material when we pull. The next one is to cut material, and the third is to not merge it if it contacts other solids. These same buttons are also active in the pop-up menu when you select a surface. You have the add material, cut material, and not merge. The thicken surfaces is by default active every time you select the pull tool. And what that does is that is what tells it to turn that surface into a solid. If I deselect that and you drag, it basically just moves that surface. It turns it into a move tool. So depending on whether you're trying to move surfaces or thicken them in your design, you can turn that off or on. The next button that is both in the tool pop-up and over in the options is the pull from center. So this basically pulls your surface in both directions from the center as a straight pull. There's one that we skipped over right here, and that's the maintain offset. I have only seen this button become active one time, so I never use it, so we're just going to skip over that. The next buttons, I'm not quite sure why they are here. The first one is the measure button, and if you click on it, it puts it into a measure mode, which is basically the same as clicking the little measure button up on the tool ribbon, and that is the ability to measure objects that are in your design. It really doesn't have much to do with pulling, but it is there. So in the options, it tells you how to set the precision, the angular precision, and the important part is the inches, the units here. So if I select an item, it can tell me the area or the perimeter, or if I select the edge, it will tell me the diameter or the circular perimeter, which is the same as the perimeter of the surface. And we can change the units of the display by the drop-down menu over here on the side in the options. This is a super useful tool, especially if you are working with belts and pulleys, because you can use the tool to quickly and easily tell the length of a belt by selecting the measure tool and then selecting an edge and double clicking it to get the overall length of that perimeter. This can work for the inside of the belt as well as the outside of the belt. The only thing you have to keep in mind is it is measuring the solid, right? So if I select an area, or if I triple click here to select the solid, the belt and this pulley are all part of the solid area. So the area that is displayed is actually the area of everything that is here, not just the pulley. In this case, this pulley is a solid in its own, so the area is going to be accurate. And that brings up the next tool in the options. If I escape out of this tool and go to the next one, which is mass, it is very similar to the measure tool, and that shows you volume as well. So if I click on this solid, it tells you the total surface area of the whole solid, the center of volume, and other information. But again, it's the entire solid. So if I select this solid, it is combining the pulley and the belt for the information that's displayed. But again, the measure tool and the mass tool have very little to do with the pull features, so I'm not quite sure why they are included in the options for the pull tool. The last button that's there, we've seen that before, and that's the ruler tool, and that basically gives you the ability, let me go back to my home view, The ruler tool gives you the ability to select an object or a reference point to measure from for your pull distance. And that allows you to enter in whatever value you want it to be to make accurate pulls or accurate dimensions. When you're using the ruler tool, you can pick almost any point in your design as a reference point. And it can even work off of other edges, other surfaces, or even off of other solids. And if you remember, the ruler tool is also available in the pop-up toolbar as well. The 5 bottom buttons in the options section all deal with working with edges, so we need to select an edge first. If I zoom out and select an edge on this cube, for instance, then we see that both the buttons pop up on the quick toolbar as well as become active in the options menu. So let's go through those real quick. The first one that is active as default is the round button, and that basically allows you to pull an edge in and it rounds it over. Remember that you can select multiple edges at the same time, so if I double click, it will do the perimeter and allow me to pull it as well. Or I can add additional edges by holding the control button down, and that will pull and round all of the selected edges. And Control Z is the undo once again. The next button over is the chamfer button. That's very similar, but instead of doing a rounded surface, it does a flat surface. It's important to keep an eye on these yellow arrows because they indicate the directions that you can pull whatever you have selected. So in this case, I've got quite a few options here that I can adjust this chamfer by pulling in or pulling these out or pulling this down to adjust the direction and the way that that chamfer is put on this object. Let me Control Z to get back to the cube. And I'll escape to deselect the edges. And if I just select one edge here, we can go to this middle button here, which is the copy edge. I wanted to show you this really quick. Once you have an edge selected, the 2 different arrows show you that I can copy this edge and pull it down this way, Control Z, or I can copy that edge and pull it across to basically split the face of this solid cube here. So this is a quick, easy way that you can divide up a face on a 3D object. Let's go ahead and throw another one on here, and we'll divide these 2 faces up like this really quick. And then we can go on to the next button, which is the extrude edge button. And this basically allows you to take an edge and extrude it in the directions that you can pull. So we can make additional features all by pulling edges on this solid object. See how that works? It makes it hard to line up and see what you're doing, and it only allows you to pull in the direction that the edge already goes. So it's not super useful for creating the parts, but a lot of times you can just extrude an edge to fill a gap between 2 parts, and that is usually done with the extrude edge tool. The last button in the options is the pivot edge, which that's kind of misleading too because it doesn't really pivot, it moves it. And once again, the direction of the arrows show you the direction that you can pull that edge. So this is an easy way to affect the edges of a solid. And you may have noticed that all of those buttons too, when you select an edge, show up as a quick tooltip up here as well. So there's a quick overview on working with edges. So now let's get back to the pull tool, and before we move on, let me quickly reset this drawing to the way it was when we started. Alright, so with the pull tool selected and the default selection for pulling a surface, then we have some more features available on the work area. The first one is the pull direction tool. I can affect the direction that we are going to pull in by selecting another edge in the design. So I'm not clicking on them, I'll just hover over them to show you how it will change the pull direction depending on what item I choose. Now if it's in the same plane as the surface itself, then there's no point in trying to pull that way, because if I select that and pull, it's not going to make anything. Escape to get out of that. And it's a one-time shot deal. So if I select a surface and then want to change the direction of the pull, once I click on it, it's now set there, and if I click on something else, it's actually selecting it to pull. So you have to go back and re-click on the set direction to pull to change it, and it's a one-time selection. Now, setting the pull direction needs to be an edge to tell it what direction to pull. Like here I have a point in the design and it has no direction to it, so it doesn't know which direction to associate with that. But there is a spline here, and the spline has points along it. If I start coming down, you'll notice that there are points on this spline, and it can set the direction that the spline goes through that point. So if I selected this point right here, you'll see it changed the direction to be parallel to that intersection right there. And this can be done again on any point in this spline. If you follow along it with your pointer, you'll see points along the spline, and you can set it for any of those locations. Alright, let me escape out of this really quick, and we'll reselect our pull tool. And there's one other thing I wanted to show you for the select direction, and that is that when I select an item, notice it has two little options here. One is the direction for the pull, and the other one is revolve, which is the same as selecting revolve up here. What this basically does, if I come back and select a surface and then change the direction to select, say, this one that is in parallel with the surface, and I use the revolve, it will rotate it around that as the center axis. And if I Control Z to undo this, come back to this surface, that is the same as selecting this revolve tool here, which tells you up in the top to select an axis to rotate about. So that would be an axis that is on a plane parallel to that surface. Now that we've selected this line, you can see how the pull direction tool indicates what's going to happen when you pull on it. So it's going to revolve around in the direction of the yellow arrow. Control Z. Once we have this set as this being the surface and this being the axis to revolve around, you might notice that another button has become active up here, and that is the full pull button. So if I select the full pull button, that is going to revolve it and make it a complete solid. Alright, let me undo that. This also has activated a new set of options in our options section on the left. And the great big one is the Revolve Helix. By selecting this one, we are telling it that we want it to rotate and move its way down and make a helix pattern. So this brings up an entry box over here. And what it is asking for, it is asking for the pitch and the height that you want to make this helix. So the value in the pitch, if you think of this like threads on a bolt, the pitch is the distance between the threads on the surface of a bolt. The same thing applies here. The pitch is going to be the distance the surface travels as it makes one full revolution around the axis. So in this case, if I wanted this circle to go completely around and come back to where it just started like a thread and continues on, I need to make this pitch the same value as the diameter of this surface. And how can I find the diameter of the surface? Remember that measure tool over here? If I escape out of this and then select the measure tool and come select the edge, it will tell me the diameter of this circle, which is 0.75 inches. So if I get back to pulling this surface as a revolve, so if I escape to get out of this and escape to deselect my surface, and if I select to pull the surface, tell it that I want to revolve around this axis and I want to do it as a helix, that brings back up our setup here, and I can change this pitch value to 0.750 inches. Once we have the pitch set, then we're ready to drag for our pull, and it should pull around and go down 0.75 of an inch when it makes a full circle. If we were to keep going, it should just keep on spiraling and spiraling. And that looks an awful lot like threads. There is another value here that we can look at, and that is taper angle. So if I Control Z to back this up, and let's put a value in here of say 10 degrees. Now when I drag, it is going to taper out positive 10 degrees. So if I get back and look at that, see how it's tapered out and it's getting bigger? I can Control Z this and we can put a negative number in here, minus 10 degrees. Now when I pull it, it is going to get tighter as it goes down. See that? The last value we have to look at is the height, and this is where it can get just a little bit tricky. Let me undo this real quick. A value in the height will cause it to automatically generate the helix. So the number of turns that it creates will be based on the pitch value. But this can get really tricky because if it is generating this automatically, it may have difficulties if the solid surface touches itself. Let me show you the example. I'm going to set this back to 0 taper, and if we wanted to make this do one full revolution, the height should be 0.750 to make the full height. I want to show you what happens here. If I put in 0.749, it will make a full revolution, and when it revolves around to where it will touch itself, you can see that there is a small gap there, so it does it just fine, right? If I go back one view here, and we undo this, if I put in a value of 0.75 and it will touch itself, it gives you an error telling you that it has failed to revolve the surfaces. Now, if I change my value here to 0.751 and I make the height 0.751, it will make a full revolution even though the values are the same, but the surfaces did not touch themselves. So you have to make sure that whatever you set for the pitch is just ever so slightly larger than whatever the size of the surface is. So if I was to escape this and Control Z, now I could set this in at say 3 inches now, and it will make 3 inches worth of that revolution. So that has kind of gotten down into a rabbit hole on the Revolve tool and the options of a pull. So let's call that good for now on that one. Let's escape to get out of this one, and let's move on to the next tool. I will be making a much more in-depth video on using the Revolve tool to make threads and other complex shapes. But let's move on so that we can get through the rest of these tool options. The next option I want to show you that is really neat is the sweep tool. This is a neat tool because this will cause the pull to follow a trajectory. So I can select, say, this spline to set the pull direction and then pull, say, this surface, and it will follow that spline as its trajectory. Let me get to a better vantage point here. Control Z, let's go back to our home position so we can see this better. And now watch, when I pull this, it actually follows that line. So this makes me think of an exhaust pipe in a car or tubing running through a machine. And again, our full pull becomes an option. So if I escape out of this and Control Z to back up, and we tell it to get going, and then we tell it a full pull, it will pull that the full distance of the spline all in one shot. So as you can imagine, this can be used to make some very interesting shapes and be used to model up tubing or piping or other features like that. The last feature we have is the draft tool. This is a neat feature because it allows you to adjust surfaces of a solid. So this is asking to pick a plane to draft about. So if we were to pick this surface here, it will basically allow you to pull other surfaces around that plane. So it uses it as the pivot point. And if I Control Z this, you can do multiple surfaces by holding the Control and selecting multiple surfaces here, and then drafting all of them will move all of them at the same time. This feature can also work really similar to, let me undo this. This feature can also work very similar to the Revolve tool. And let me show you how that works. If I escape out of this to deselect it, and I tell it we want to revolve around this edge, and this is the plane we want to work with. So if I select a face, and then I select the draft tool, and I select, say, this edge, then I can tell it that I want to revolve around that edge. And so what happens is it still does the same draft feature until it gets up to the 90-degree mark. And at that time, then it starts revolving around, and it becomes a way of pulling that surface and making it make a complete round around that edge. Control Z this to back up. So if I was to quickly draw a sketch on this surface, just to make it simple, if I draw an arc, and then we want to pull that surface, I can select the draft tool, and I can select this edge and then tell it I want it to revolve, and then when I select this surface, when I pull, it will then pull that around the edge there. And if I keep going, I can go a full 360 degrees and make a sphere out of it. But if I only wanted to go, say, around the corner to the 180 mark, then that adds that arc, turns it into a half of a sphere right on the corner of that solid. Alright, I'll Control Z to undo this, and we'll get back to our solid here. The last item in our features is the scale body. Now this tool has a couple requirements. Let me go back to my home position here so that we can see this. You can select any body to scale, but it has to be a body. So in other words, I can't scale a surface. So I can't select this surface and scale it because it just doesn't work. There's nothing there to scale. So the first requirement is that it has to be a body. So if I select, say, this body here, and I tell it to scale, the next requirement is that there needs to be an anchor point to scale the body from. So this scale point can be any other point or corner in your design. And since it's followed this spline, I can even select a point on the spline. This comes in really handy because this is close in relationship to our part. So then when I click this point, say on the end right here, then we can scale this, and it's all in relationship to a reference point that is part of that solid. If I Control Z this to back it up, and instead if we scale this to, say, this point here, we can see that it will skew the direction and the location of the part as we scale it. Let's say I wanted to scale this cube. If I select it as a solid over here, and I really need to scale this object, and I don't want it to move around and to be skewed in its location, how can I do that? By selecting a point on the object itself, and then it grows from that point. And that can be done from any point in the object. So we can change points and grow it in this direction, or select another corner and pull it in another direction. The arrow, again, indicates the direction that it's going to grow. And I guess there's one more that we kind of forgot, and that's the up to tool. So when you're pulling surfaces, let me show you that really quick. If I just do a standard simple pull, you can tell it to pull in the direction of the arrow up to a point, and that's easy enough to do by doing the up to and then finding a point to pull it to, and it will pull that surface up to that location. really similar to the Move tool. Alright, that about covers it for making shapes by using the Pull tool. And as I said earlier, I plan on doing some more in-depth videos on a lot of these features that are really complex, like doing threads or making custom shapes. So I hope this information helps you out, get your feet wet, and allows you to explore and play and have some fun. If you liked the video, please hit the like button. And as always, if you haven't subscribed yet, go ahead and subscribe and ring the bell so you stay up to date on all my future videos as I release them. And again, as always, thank you very much for watching.